Okay, guys, we're going to start a new unit right here, triangle congruence. And we're going to start out by just talking about and reminding you what congruence is in the first place. And we have probably said this in class before, just defining congruence versus similar. Remember, congruence is same size and same shape. Whereas we just finished a unit about similarity where we said they were the same shape, but they were a different size. So this is to get more specific into this. What makes them, how do we measure and see if they're the same size? This is all corresponding sides are congruent or are the same length. And over here, what gives them the same shape is that they have all corresponding angles are congruent, right? So everything is the same. And just to get your mind thinking back to similarity, the first few examples right here ask us to verify whether these two shapes are similar or not. And one of the easy things we could do is to use some tracing paper and check and verify that. So the thing to do would be to put this on here, carefully trace, and then I'm going to put that over there and see if I can get it to match up perfectly. Actually, it's off by a little bit. It's actually not. Okay, and it looks like some of these angles down here are actually a little bit different size. That one's really close. Let's see if we can do some counting right here. This side down here is 1, 2, 3, 4, 5, 6. This one's 1, 2, 3, 4, 5, 6. That's the same. If you look at D right here, if we were really going to check the length of this side, all right, what I would have to do is complete the rise and run, which is 3 by 12. And if I was going to match that up over here, well, if you look, this one is 2 by 12. So we know by Pythagorean theorem right now that those two sides are actually going to be slightly different in length. The other thing we could check on this one is to verify some angle measures. I see that this angle measure down here is about 81 or 82 in this angle right here. And if I check the angles over here on this side, get that matched up, they are below 80. You can see that they're about 77. And I think this one over here, this one's isosceles, it's about 77. So right now I have some discrepancies, and I'm going to say for this answer right here, these are not congruent because angles and sides differ. There is my evidence there to back that up. So you're seeing we're using a lot of ways to check this. I can look at some Pythagorean theorem. I could use a tool like this. I could use tracing paper and determine. And so that's what I want you to do right here. I want you to verify that all six parts of this triangle are congruent to all 6 parts of that triangle, because these are really drawn really close. They may or may not be. Okay. And then after you finish that, you might want to pause the video and do that first, and we'll check our answers in class. When you do that down here, just remember we were doing some translations, rotations, and reflections. There's the big 3 right here. And when we do these, for example, if you reflect this triangle right here across the y-axis, so A, F, and P, if these reflect across the y-axis, so I'm going to flip that over there. There's the origin. I think this part over here will be pretty easy for you. So there is our new location We'll see if those superimposed through there. You can do this with some tracing paper. You could also reason it out because we know how to do reflections. But let's just go back and review just reflection, for example. Is the image congruent to the pre-image? We answered this question before when we first started doing these. So this is the reflection one right here. Yes, we know that it is. We know it. We can take that triangle right there and match it up over here exactly. All of the points correspond. So that's also the question down here. Yes, image congruent to pre-image because all points coincide, I think was the word we used, which is essentially going to make all of the sides congruent and all of the angles congruent if all of the points coincide. All right. We call these three right here rigid motions because rigid motions preserve congruence, which means the image and pre-image are going to be congruent. It was the dilation one that did not. Okay, and we just completed an entire unit based on the dilation, which was resulted in similarity. All right, so you do these over here. You can do that for your work. We're just throwing the idea out here that all of these are going to have congruent results, and we're just trying to really hit on the idea of what it means to be congruent.